Welcome back to my YouTube channel, and the question for today is candy. So basically there are n children standing in a line and each children has assigned a rating value, alright, in an integer array given to us in that is ratings. So basically we have to distribute candies to these children as per the following requirement. Like each child must have at least one candy. So there are n number of students, so n candies should be there for everyone, that is one candy for every student. Also the children with higher rating get more candies than their neighbor. So suppose there are three children, one is having rating 1, other is having rating 2, and again one is having rating 1. So this student, if they are getting all 1 candy, but this student get a higher candy than its neighbor. So neighbors, what we say is the adjacent elements, that is the I plus 1 and the I minus 1 element. Yeah, I plus 1 and I minus 1 might not exist in the corner, but yeah, for any element there should be the neighbors that is alright. So for this it should be 1 to 1, and we have to return the number of candies, that is the sum of the candies used. 2 plus 3 plus 1, that is 4 in this case. Alright, so this is the question statement, and there are the that are also given to us. And now moving on, let's see the constraints for the problem. The constraints for the problem is that n is the rating length, and n will range from 1 to 2 to the power 10. So n can't be 0. So we don't have to think about the 0th case, and we don't have to put the check for that as well. Now moving on, the values could contain, that is the rating could be read up to 2 to 10 power 4. Alright. Now all these are the things. And now let's see how we are going to solve this problem. Alright. We will look this with the help of an example. Alright. Now moving on, let's see the approach for this problem. Alright. So let's see how we are going to solve this problem with the help of an example given. Alright. For the approach for this problem, let's see first of all an example. So basically the ratings given to us are 1, 2, 3, 1 and 0, because the rating can be 0 as well. Alright. Initially what we are going to do is we are going to pass it in, we are going to take two arrays. Alright, one is for this pass and another is for this pass. Alright, and based on that we will update the values, and finally what we are going to do is we are going to pick the maximum value that is assigned to a particular level. Why maximum? Let's see in the approach. Alright, so initially all will be ones, corresponding to every student gets one candy. Now we will see that if this value in the left pass, we will see that if the left value is greater than the previous value, then we increment its count. Alright, since it's 2 is greater than 1, we increment the count to 2. And since 3 is greater than 2, so the number of candies this would be getting would be 1 plus than that. So it is 3. Since these are less, so it remains that. So up till now the left array is filled. Now right reversal. Now since from here to here, since 1 is greater than 0, because we have to look for both the neighbors and then decide how many candies to allocate. So since it's greater, so what we are going to do is we are going to update it over from 1 and we are going to update it 2 over here. Alright, for this. Now since 3 is also greater than 1, so it would be 3 for that. Since let's are all are small, so yeah, this is how we have the final count. Now we will choose the maximum value and we will get a final array. Alright, so the final array would look like 1, 2, 3, 2, 1. Alright, these will the number of candies, and sum of all will give us our final answer. So 3 plus 2 5, 5 plus 2 7, 8 and 9. Alright, because in the one pass we are just looking for the values that are greater and incrementing likewise, and in the another pass we are just looking at the another values and incrementing likewise. Alright, and in this time we cover both of the we cover both the left neighbor and the right neighbor, and to allocate the answer we just find the maximum of these two. Alright, so I hope the approach is clear to everyone, and let's see the code for this problem. And the code would be very simpler, and if you want to make it a much more simpler problem, I would say that update it in a one pass. That is, if we go from left to right, just take the single array for both of the iterations. That would also simplify the approach in case of the space complexity. Alright, so time complexity in all the case would be O of n only, but the space complexity could be optimized a little bit while not considering the second pass array, and just taking the sum away. Alright, now let's see the approach for this code for this problem. Alright, moving on towards the code. So yeah, here is the code. I have taken initially the sum variable, that is the final answer, and initialized to 0, and I have taken the two arrays left, right and right, left. You can optimize it a little further with the strategy I have told, but I have not used that. Alright, so I have just make it a simpler code that would be easy to understand to everyone. Now moving on, that for the first pass we will see that if the number is greater than the previous value, we update its left right array and value count, that is the count for candies from moving from left to right. Similarly, if the right to left is greater, we increment the count. Now at the end we take the maximum of both and perform the sum operation, and hence our final answer would be stored in the sum variable, which is returned at the end. So let's try to submit this code. So as you can see, it's accepted. So if you have any doubt with the code, regarding the code and or the approach for this problem, please feel free to reach me in the comment section. I will surely reply to every one of you. And if you like this video, please press the like button, share it among your friends and subscribe to my YouTube channel. Thank you for watching. Bye bye.